Okay, so we'll start with 0. Cotangent at 0 is what, Max? 0? Agree? Kristen said no. Was cotangent at 0? Emma? Undefined. Would you guys agree cotangent is x divided by y? Is it x1 and y0? Yeah, it's undefined. Okay, so asymptote right away. Cotangent at pi over 4. This one goes to Ruby. What is that, hon? If you're not sure, consult with your team. This is teamwork. One. Perfect. Cotangent at pi over 2. Emma? Perfect. Cotangent of 3 pi over 4. Caitlin, Emma. Thank you. Cotangent back at pi. Sophia, D. Thank you. Very good. And here is our nice decreasing curve. And then once you have that, I'm just going to repeat the pattern. Okay? 0, 1, and -1. By now we know, is this a 1-to-1? No. Okay, because we said no. What's the reason why we restrict things to 1-to-1? Right, so the inverse can be a function. Now look at it. Where are we going to cut off? Yeah, this one's nice. Okay, one continuous curve from 0 to pi. Beautiful. Now, just like always, we are going to flip over and switch x and y. X equals cotangent of y. Then we are going to compose both sides by cotangent inverse, so we can have a y equals. Okay, so we are cotangent inverse of x equals y, which we use the notation of f inverse of x, just like that. So we are now going to state the domain of our inverse. What is the domain of our inverse? All reals. Because the range of that is, the regular is all real. So this is all reals. What's the range of our cotangent inverse? 0 to pi. Now, as you know by now, I do relate these back to the quadrants. What two quadrants is cotangent inverse in? 1 and not 4. 1 and 2. Okay? So now we have all 6 of the quadrants. I mean all 6. All 6 of the inverse functions. So let's recap. What trig inverse belongs in 1 and 2? Sine is not in 1 and 2. Sine is 1 and 4. Cosine, yes. Cosine inverse is 1 and 2. What else?
Secant.
Secant. What else? Cotangent inverse. So those are 1 and 2. What? The trig inverse that is 1 and 4. Sine inverse. What else? Cosecant inverse, because it's reciprocal, and then tangent inverse. So there is anything in 3 ever? No. So it's either 1 or 2 or 1 and 4. Okay. So we are going to, yes, Zen.
Is there like a reason why like cotangent doesn't do the same as its like original?
Oh, because the 1-to-1, honey. Because the 1-to-1 is, if I were to cut off it here, like what you wanted, right? The reason that's, okay, if I cut off right there, it's fine, but what happens to these 2 dots? Yeah, so they're not going to be 1-to-1, you know? So that's why they just go this route. And plus, it's prettier from 0 to pi, because it's more continuous. Okay. All right, let's graph out our regular from 0 to pi. And then we'll switch the point to do, so here's pi, here's negative pi, up a pi, down a pi. And then we have a negative. So these are by quarters. Each tick mark is worth 1/4 of a pi, okay? Then I also need a 1 tick mark. Can I put a 1 tick mark 1/3 of the distance from 0 to pi?
Yeah.
Yeah, so here we go. 1, 1, -1, and -1. Okay. Asymptote for the original, we will have one asymptote right at 0, just like that. And then we have another asymptote at pi. So there's that. Okay. So this is your original. Okay. The original has 3 dots. At pi over 4, how far high up do we go? 1. Very good. So I'll label this dot. Pi over 4, comma 1. The reason, if I label it, you can easily switch it later. At pi, where do we go for the original? 0. So pi, comma, I'm sorry, pi over 2. Woo, pi over 2. Thank you. Good eye. Pi over 2, comma 0. And then 3 pi over 4, we are going to go down at -1. Yeah. Right there. I'm going to label that 3 pi over 4, comma, -1. Okay. It's easier to switch the points if it's already labeled. So this is your original. Now we're going to do an inverse. Where should we put the asymptotes? Pi on the y-axis, right? Right? And then where's the other one?
0.
Yep. Perfect. 1 and 2. So here's our inverse. Now I would also need 3 dots. Dot number 1. Yeah, 1 is my red. Pi over 4 is the first tick mark. So here's 1 over 4. Assume that's a... Okay, so that's 1 comma pi over 4. Where's dot number 2? 0 pi over 2. So pi over 2 is on the y-axis now. Would you guys agree? Last dot. -1 up to 3 pi over 4. In my case, that's my third tick mark on the y-axis. And I'm going to try to graph that out. Okay. So that is what cotangent inverse looks like, guy. Does it look like it's symmetrical about that disco line, y equals x? Yeah, right? So totally. Now, we are going to come back to method number 2, but right now, let's go to example 2. Example 2 says, find the exact value. Calc or non-calc? Non-calc. Do you know how to find the answer to 2a? Yes. Try. Find the answer to 2a. If you don't, that's okay. Just talk to your friends about how to. What are the steps that you would need to take to find it? Oh, yes. Here we go. Talk it out. Communicate with your friends. If you don't remember from Algebra 2 trig, totally okay. Just go and...
No.
We have an answer.
Because there's no 2 on the right? There's a 1/2. So then
Okay, just who has an answer? What is the answer? Uh-huh. Pi over 6? Now the question is how? Tim.
I used the method that you taught
Sure.
me.
Okay.
I said that cosecant inverse 2 is equal to a blank box.
Thank you.
Then I took the inverse of that, which was the cosecant of the blank box equals 2.
Okay, so hold on. I need to write. Okay, so like that. Perfect.
Yeah. And then I rewrote it as 1 over sine blank box is equal to 2.
Beautiful.
And then I just kind of plugged in numbers to see like 1 divided by whatever the sign in that restriction would be equal to.
Good job.
It's 1/2, and then that's corresponds to 5 or 6.
Yeah, perfect. Would you agree? Technically, I can go and flip this equation. I'm going to go and turn the right side upside down, and if I turn the right side, I have to also turn the left side. So would it be okay if I continue Tim's method and go, okay, is that still equivalent? Now you should know this, right? You should know sine of something, in this case, empty box equals 1/2, and that empty box is pi over 6. Now try B. Because cosecant, remember, goes from +1 to infinity for the positive side.
Oh, right.
Remember you asked me yesterday, how come it goes up forever? Yeah. Yes, 2 totally would totally fit.
I was trying to make sure it wasn't perfect.
So try B. What do you have? Okay. You guys all have the same? Now, if you know how to do these straight up, can you just go straight? Sure. Okay. We're going to fix this answer, right?
Yeah.
Okay. All right. How do we get the answer to B? What would you do? If you know the answer right away, what's the answer? 5 over 3? Okay, if we don't, we're going to use Tim's method. Give it a box. We are now going to compose both sides by regular secant. Would that still be okay? Secant is 1 over what? 1 over cosine of my box. Can I flip it? Yeah. Okay. You don't have to flip it if you already know, but some of you are better at using sine and cosine and tangent. Okay. Final answer. That's right. Okay. This is what I'm going to test you to see if you can give me the right answer for C. By the way, who worked out C already? A couple. Okay. Why don't I give you another 30 seconds to see how far you can go with C. And if you can do D, go. Actually, you know what? Don't do D yet. Just do C, just in case. Just in case. Just do C. I'm going to bribe you if you guys have the right answer. I'll give you, this is what I got. Okay. If you got the right answer on C, okay, ready? Who thinks they got an answer? What do you have? No? Yes. How do you know? You want it? Hey. Yes, because of our restrictions is right. Cotangent inverse is in 1 and 2, okay, which is slightly different when you borrow tangent inverse. Would you guys agree with that? Yeah. Okay, so same thing. I'm going to use method number 1, which is Tim's method here. Same thing. I'm going to go, okay, I will now compose both sides by regular cotangent. If you like tangent better, convert to 1 over tangent of theta, or in this way, a blank answer. Then I'm going to flip it to say tangent of some box equal to negative 1 over rad 3. I do not need to rationalize because that's not my final answer. Then I know, right? I know tangent inverse is in quads 1 and 4. Tangent inverse, okay? But think about this. My original is not a tangent inverse, okay? My original, because this is tangent inverse in quad 4, which, by the way, I saw a lot of you have what angle? Negative pi over 6. But my original is a cotangent inverse. So that means it has to be in quad number 2. Okay. The reference angle means it's always positive. The reference angle is still pi over 6. So that means that big, ginormous empty box should be filled in with 5 pi over 6. Okay. Now this will lead me to method number 2. Feel free to do that all the time. Okay. Here's method 2, which will help you not worry about the restrictions using tangent inverse. So method 2 will require tangent inverse still, but we are going to manipulate tangent inverse. So tangent inverse was from negative pi over 2 to pi over 2. Would you guys agree? When we graphed it out? Okay, so here we go. Negative pi over 2 all the way to pi over 2. We are about to graph tangent inverse. And then tangent inverse had an asymptote at both of these ends. Do you guys remember this? Okay. And then so we're going to go up. Oh, actually, you went sideways. I need to go sideways, sorry. I'm graphing tangent inverse. Pi over 2, negative pi over 2, asymptotes here, asymptotes here. Okay. So the green ink is, I'm about to graph tangent inverse, okay? So look at your tangent inverse and tell me what dots can we use. One of the dots for tangent inverse, what did you guys have?
0, 0.
Yeah, let's start with 0, 0. Perfect. Definitely 0, 0. How about one more dot? Yeah, 1 pi over 2 is, pi over 4, you mean?
Oh, yeah.
Yeah. So 1 tick mark will be 2/3 of this distance, okay? So 1 pi over 4 is halfway, so there you go. Perfect, good job. One more dot for tangent inverse.
Negative 1, negative 1.
That's right, negative 1, negative pi over 4. So this is your tangent inverse. You still have it in your notes packet, okay? And hold it tight so I don't go too fast. Now we are going to also sketch out cotangent inverse, which we just got done doing. Cotangent inverse have asymptotes from 0 to what? Cotangent had one asymptote is 0, right? Which I want to make it 0 to pi. Pi is right here. Is that okay? Here's a pi. One asymptote right here. Yes, no, maybe? And then one asymptote right here for cotangent inverse. The black is y equals, bless you, cotangent inverse. Okay, there's the black. Then I got 3 dots again for cotangent inverse. Dot number 1 for cotangent inverse. Just look above a previous page for you. What was one of the dots?
Negative 1, 3 pi over 4.
Negative 1, 3 pi over 4. Perfect. Then what else? 0, comma,
Pi over 2.
pi over 2. Then we have one more dot. 1, comma, pi over 4. So it looks like it's that dot. They both have that one dot in common. Okay, so that's your cotangent inverse. Okay, so how are we going to do this? I would like for you to take the green, which is tangent inverse, and move it or flip it or whatever you want to do. Rotate it so that way it will look like the black. What would you do first? Right?
Reflected over the x-axis.
Yeah, let's do that. Can we do that? Can we flip it?
Mm-hmm.
Okay. So I'm going to write that down first. I'm going to take the tangent, which is the green, tangent inverse. Tangent inverse. And Ray said reflect it. Where would I put this negative?
In front of the tangent.
In front. True or false? Right. Let's stick it in there. Okay. We flipped it. So now it's upside down. What else do you have to do to make it look exactly like the block?
Add pi over 2.
Yes, we're going to move it up. 5 pi over 2. Gorgeous. Okay. So that's exactly right. Okay. That right there, those transformations will make it look like the black graph. So from now on, if you do not want to worry about restrictions, class, you can find cotangent inverse using that right there. I'm going to put the pi over 2 in the front, so that way you don't have to worry about the negative. You can take pi over 2, take away tangent inverse of the same value x, whatever x is.